Hi, my dears. In this session, we'll be discussing on the refraction of light. We learned that light travels in a straight line path in a transparent medium. And here we see what happens to the ray of light when it travels from one transparent medium to another transparent medium. These are phenomena that could be explained by the refraction phenomena of light. So we'll come to these explanations a little later. Let's go for the refraction. By definition, refraction is the phenomena of the change in the propagation of a light ray when it travels obliquely from one medium to another. In other words, we can say when light travels obliquely from one medium to another, there will be a bending in the path of the light ray. And this phenomena is called refraction. So the two conditions of refraction is that there should be definitely at least two mediums, or there should be a change in the medium for the light to propagate, and the light should fall obliquely to the medium. If in case the light is falling perpendicular to the medium, what happens? It will trace the path of the normal. In case if it is perpendicular, what happens? See, it will be tracing the path of the normal. So the light will propagate in a straight line. So here what we see is the light is falling obliquely. So there is a change in the direction of the light is what we observe. That is, this will be the normal path of the light which we expect, but this is what we get. So why this change in the path? It is because of the phenomena called refraction. So this refraction we're explaining with the refraction of light through a glass slab. So this is in your NCERT. So if it comes in your question paper, this is how you will be answering. You will have to draw the diagram, and you will have to mark the air and the glass, and A, B, C, D as your glass, or notify your glass slab and your incident rays. Okay, so at the point of incidence, you will have to draw your normals n and prime, and here after the light enters as in an oblique path, this is the angle of incidence that you make with a normal, and this angle which the incident ray makes with the normal is called refracted ray. That is the incident ray will enter the glass slab and it is refracted. So this angle which the refracted ray makes with the normal is called angle of refraction. In reflection, we learned I is equal to R, but in refraction, I is never equal to R. The refracted angle of incidence is never equal to angle of refraction. Okay, this incident ray makes angle I, that is angle of incidence with normal. The refracted ray makes angle R, that is the first refraction angle of refraction with the normal, that is angle R1. The refracted ray, then it comes out into the air. So this is a glass is a denser medium. So this will be your incident ray at this particular point. That is O prime. O prime is where the refracted rays emerging out of the glass slab. So this emergent ray will come out from the point O prime, and you draw your M prime as your normal there. So you get your incident ray as your O prime, and O prime H will be your emergent ray. So these you will have to mention in your you'll have to draw your diagram, and you'll have to mention these points and what these points represent. Okay, so as we already discussed, I'm not going into the details now. You can take a screenshot of the page. Then here the emergent ray OH, that is O prime H. O prime is your refracted ray, and O prime H is your emergent ray. That is a ray that comes out of the glass slab. So O prime H is parallel to the incident ray. This incident ray, if you extend this line in a parallel direction, this is how you will get it will extend, right? So this ray, that is this ray and this ray are parallel. Why these two are parallel is basically because the extent of bending of the ray of light at the point of incidence in this slab, that is AB, and the extent of bending of the light ray at this point O, that is at this juncture of glass and air at the point CD is equal and opposite. In a way, we can say angle I and this R2, that is actually the angle of emergence, angle E, which will be equal. And that is why these two rays, that is the incident ray, that is this particular ray, and this O prime H are parallel rays, because this angle, the angle of incidence at this point, and on this interface of air and glass, and this glass and air are equal and opposite. We already discussed if it is perpendicular, what will happen. And yeah, the refraction phenomena is basically why, because the light, because of the optical density of the medium. So in your questions, there is a chance that you get, sometimes they may say it is rarer and denser medium, but there are times that you get transparent and translucent. So transparent is the rarer medium and translucent is the denser medium in that case. Or you get clear and opaque medium, which again means the clear medium is a rarer medium, the opaque medium is a denser medium. So clear medium means what? Or the rarer medium means the molecules of that medium are loosely packed. While in the denser medium, the molecules are closely packed. Just how when if there is a traffic, you are not able to travel smoothly. Just like that, when there is no traffic, the vehicle will move easily. And if there's a traffic, the vehicle will move slowly. This is exactly what refraction is also all about. In this case, the molecules are loosely packed, so it can move freely. And here in the denser medium, light will not move freely because the molecules are closely packed. So this property of that particular medium is called optical density of that medium. That is, it is the optical density is that property of that medium that will determine the speed of light in that medium. So if the rarer medium means the optical property, the optical density is less, so the light will freely flow. When a denser medium means the optical density is more, so light will not easily move through. Okay, so we need to know that the optical density will be different for different medium, and that is why the propagation of light also in different medium will change as per the optical density of that medium. Okay. And now we would like to explain those phenomena which we saw in the pictures. Okay. So you get a pencil that was immersed in the water and it got displaced, or the stick which looks displaced, or the lemon looking bigger. Basically, because the light reaching you from the portion of the pencil or the lemon or inside the water will come from a different direction, and the portion that you're observing outside the water, the light ray will be coming to your eyes from a different direction. See, you see something when the light ray, as per the light ray that emerges out of that reaches your eye. So based on how you're looking and from which place you're looking, you will see you will see things differently. Okay, that is, if you're looking, say, in from perpendicular to the pencil, or perpendicular from the top, it may not you may not get that much of a displacement. But if you're looking from the sides, you will get the displacement quiet, or the pencil being broken, like two different pieces you will see. So basically, it is because of the refraction of the light, because the light will move closer to the normal when it enters a denser medium, and it will move away from the normal when it enters into a rarer medium. Okay. And this is explaining why your bottom of the pond is looking raised. That is, as I mentioned, your eyes, when you look from a point, this is the real position of the object in the pond. But it will appear to look from the point, say, B. Why? Because this change in position is otherwise called lateral displacement of the object. And this lateral displacement is an illusion. Why? Because of the light, the bending of the light ray at this interference of water and air. So you with this is your eye, rays that are reaching your eyes. So your brain tends to create an image of the object in the at this particular point while the object is actually here. And this lateral displacement is the reason why, or this lateral displacement happens, and you look at, you feel that the object is raised to the top. And yeah, this is again again this the refraction is the reason why you see a raised the letters under the glass slab raised, mainly because of the refraction. That is when these light rays that are reaching your eyes through the glass slab will be bending towards the normal, due to which you will get an embossed and or enlarged picture of those letters. That is, a letter appear raised as a light reaching you from the letters under the glass slab seems to come from the different direction. So here I'll wind up the refraction topic. The only two things that you have to remember here is the light moves closer to the normal as it enters a denser medium and moves away from the normal when it enters a rarer medium. There was a funny story that I remember. Tim and Tom. Tim had a son called Tom, and Tim had and it was a PTA meeting of the school. So the father is a well-respected man of the society. He will never, scold his son in front of others and all that. So this is the school area. Okay. So at the moment he reaches his house, he will move closer to his mother, because the mother will be the normal between the father and the son. So he will move closer to his mother, and he will then that's how he'll escape his dad's whack. And the moment and the evening they had a party away from home. So again he will move away from his mother, because in front of others his father never used to shout at him. So this is a funny story. If in case if you, none of you can remember where exactly is this moving to. So at home he will move closer to the mother. Tom moved closer to the mother, and away from home, he will move away from his mother. Is what is a funny story to remember this. Yeah, and about optical density, the more denser the medium, which means the molecules are closely packed, so it will not allow the light to easily pass through. So optical density is more, the speed of light will be less. Okay, so bye dears, thank you for your attention.